Hi everyone, in this video we're going to learn about complex numbers. We are going to add, subtract, multiply, and divide complex numbers, as well as learn how to simplify powers of I. First of all, what is I? You know that we can take the square root of positive numbers. The square root of 9 is 3, the square root of 4 is 2, the square root of 100 is 10. We know that. Now, we cannot take the square root of -9 because there is no number that's going to multiply by itself twice to end up with a negative number. A negative times a negative is always going to give me a positive. And so to work around this issue, mathematicians have invented complex numbers. And that is basically a system where you're going to now have an imaginary number I, which is going to be defined as the square root of -1. So that means that now we have a system that's created to work around this issue of taking the square root of negative numbers. So when you see a problem like the square root of -9, this is going to equal 3i. If I have to find the square root of -4, this is going to equal 2i. If I have to take the square root of -100, now my answer is going to be 10i. And if you multiply I times itself, what you're going to get is that I squared is equal to -1. And that is such an important workaround sometimes to go from a complex answer. And in these computations at the end, sometimes you're going to be left with a real number answer. So it's actually pretty neat. I is an imaginary number. When we talk about the sum of a real number and an imaginary number, then that's what's called a complex number. So we're going to write it as a plus bi, where a is the real number component and bi is the imaginary number component. And this is what's called in a lot of textbooks as writing this in standard form. So that means that if you get an answer, and let's say that you're going to write 4i plus 7, you do need to take the time to rewrite that as 7 plus 4i, because that is how you write a complex number correctly. You always want to make sure that you have the real number part first and then the imaginary part. If you end up with an answer that's just 5i, for example, and you're asked to write it in standard form, in the form a plus bi, then you're going to write 0 plus 5i. And if you get an answer that's like 5i, that is what's called a pure imaginary number because there is no real component to it. One of the things that you may not realize is that there is such a thing as a complex plane. In a complex plane, you still have two axes, just kind of like the regular coordinate plane. But in this case, what's going to go on what we normally refer to as the x-axis is going to be the real part of the complex number. And then on the y-axis, we're going to have the imaginary component. So if I look at graphing -2 plus 3i, you can represent this as the ordered pair -2, 3. And so here on the graph, I'm going to go ahead and do my little subdivisions. On the real axis, I am going to go to -2, which would be somewhere here. But remember, that's not where I'm going to plot it. I'm just showing you so you can see where the thought process is. So I would go to -2 on the real axis. And then on the imaginary axis, I'm going to go up to +3. So my final point is going to be right there. So that point represents the point -2 plus 3i. Graphing complex numbers on the complex plane is really not complex. It's not complicated. It's actually fairly easy. You just have to remember the real part of the answer is going to get graphed on the horizontal axis, and then on the vertical axis, the one that goes up and down, is going to be the imaginary component. So just for fun, let's go ahead and do one more of these. Let's say that we want to plot -4 minus I. Think about where you're going to put this. You would have to go -4 on the real axis, so left 4 and then down -1. So that's -4 minus I. Hopefully you got that correct by yourself. In terms of adding and subtracting complex numbers, it's super easy if you know how to combine like terms. It's basically exactly the same thing. Let's take a problem like 3 minus 4i plus 2 plus 5i. We are just adding. So again, we're going to combine like terms. 3 and positive 2 are both the real components. So we're going to get 5. Then I also have negative 4i and positive 5i. So that's going to give me positive I. And this is written in the form a plus bi. So this is my final answer. Take a look at this subtraction problem. In terms of subtracting before you can combine like terms, one of the things that you have to be careful with is that you do have to distribute that minus. So the left part right now does not get touched. It's still negative 5 plus 7i. But here we're going to go ahead and distribute. Negative times a negative is a positive 11. Negative times a positive is going to be a negative 2i. So this means that now I can go ahead and combine like terms. I have negative 5 plus 11, which is positive 6. And then 7i minus 2i is going to give us positive 5i. And that's my final answer. In terms of multiplying, again, we're just going to distribute the way we normally would distribute. 4 times 2 is going to equal 8. 4 times 5i is going to give us 20i. So the answer is 8 plus 20i. Okay, so on your screen, we are still multiplying, but in this case, when we distribute, you have to be very careful. You're multiplying a complex number by another complex number, so take it a little bit at a time. Here, 4 times 2 is going to give me positive 8. 4 times negative 5i is negative 20i. 3i times 2 is 6i. And then here, 3i times negative 5i is negative 15i squared. Now, one of the things that I told you at the beginning of the video is that I squared is equal to negative 1. This is really important because right here I can start combining like terms. Negative 20i plus 6i, which of course is going to give us negative 14i. So I'm going to write down 8 minus 14i. But right here, be careful because I squared is just negative 1, which technically means that it's going to change the sign of that negative 15. Negative times the negative is going to be a positive 15, which now I can combine like terms because positive 8 and positive 15 are both now real numbers, and my final answer is 23 minus 14i. So in terms of getting things wrong, most of my students do really well with the adding, even the subtracting, as long as they remember to distribute that minus, and the multiplying when you just have one term. But we're going to go ahead and practice another one of these problems because that's where sometimes students lose themselves. So again, we're going to go ahead and distribute. 3 times 2 is 6. 3 times 3i is 9i. Negative 4i times 2 is negative 8i. Negative 4i times 3i is negative 12i squared. So hopefully you start to realize this is technically just positive 12 because negative 12i squared is negative 12 times negative 1, which is positive 12. So when I combine like terms, I'm going to have 6 plus 12, which is 18, and then 9i minus 8i is positive I. So the answer is 18 plus I. Before we talk about dividing complex numbers, we need to talk about what's called a complex conjugate. Now, a complex conjugate, in order to find it, is the easiest thing ever. The complex conjugate of a plus bi is simply a minus bi. And notice that the only thing that changes is the sign that's in the middle. That's all that changes when you are finding a complex conjugate. What is the purpose of the complex conjugate? The idea is if you multiply a complex number by its conjugate, you're going to end up with a real number. The imaginary parts of this are going to disappear. A times a is a squared. A times negative bi is negative abi. A times bi is positive abi. And then bi times negative bi is negative b squared I squared. Remember that this right here is basically going to just be positive b squared. Once again, negative b squared I squared. The I squared is just negative 1. So this is positive b squared, which really tells me that I'm going to end up with a squared. The negative abi and the positive abi are going to cancel. And then, of course, we just said that negative b squared I squared is just b squared. And this is going to be a real number. So when you look at a division problem, like the one that you see on your screen, 2 plus 5i over 4 minus I, we cannot be left with an imaginary component, a complex number in the denominator, which means that I'm going to have to multiply both the numerator and denominator, top and bottom, by what's called the complex conjugate. In this case, because I'm trying to get rid of the denominator, the complex conjugate is going to be 4 plus I. So I'm going to multiply top and bottom by 4 plus I. In the numerator, I'm going to go ahead and distribute. 2 times 4 is 8. 2 times I, 2i. 5i times 4 plus 20i. 5i times I plus 5i squared. All over. Then in the denominator, I'm going to do the same thing. 4 times 4 is 16. 4 times I, 4i. Negative I times 4, negative 4i, which I expected because remember I just showed you that those two middle terms are always going to cancel out when you multiply a complex number by its conjugate. And then negative I times I is negative I squared. Let's go ahead and start simplifying this problem. In the numerator, this positive 5i squared really means negative 5. So I have positive 8 minus 5, which is 3 plus 22i. Hopefully I didn't lose you there. 8 plus 5i squared means 8 plus 5 times negative 1, which is 8 minus 5, which is 3. That is where this 3 came from. Then in the denominator, this negative I squared really means negative 1, so it's going to be positive 1. So the 4i and negative 4i will cancel. I'm going to be left with 16 plus 1, which is 17. And in a lot of books, you're going to have to split this up so that you write it in standard form, a plus bi. So they're going to ask you to write 3 over 17 plus 22 over 17i. And that's going to be your final answer. Last but not least, we're going to talk about simplifying the powers of I. The powers of I repeat themselves every 4. I is, of course, just I. I to the second power is negative 1. I to the third power is really I squared times I, which is negative 1 times I, which is negative I. I to the fourth power can be broken up I squared times I squared, which is negative 1 times negative 1, which is 1. So this pattern of I, negative 1, negative I, 1 repeats itself over and over every 4. What do I mean by that? Let's go I to the fifth power. I to the fifth power can be split up as I to the fourth times I. I to the fourth is 1, so this is 1 times I, which is I. I to the sixth power. I to the sixth power can be broken up 4 and 2. So I to the fourth, I to the second, which is 1 times I squared. I squared is negative 1. 1 times negative 1 is just negative 1. I to the seventh power. I to the seventh power is I to the fourth times I to the third. I to the fourth is 1. I to the third is negative I. So we end up with negative I. What happens with I to the eighth power? It's I to the fourth times I to the fourth, which is 1 times 1, which is 1. This pattern is going to continuously repeat itself. It goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. And if I were to do this up to I to the 20th or I to the 24th, you're going to see that every single time it's going to repeat itself. Because this pattern repeats itself every 4 times, when you get a bigger number, like I to the 11th power, one of the things that you can do is ask yourself, how many times does 4 go into 11? 4 goes into 11 2 times. 4 times 2 is 8. Remainder 3. And what we care about is this remainder. Because of the fact that we have a remainder of 3, that means it's going to end up just like I to the third power. So that means that this simplifies as negative I. Let's try another one. I to the 19th power. So how many times does 4 go into 19? 4 goes into 19 4 times, because 4 times 4 is 16. Remainder 3, which of course is bringing us back to negative I. I wanted those to have the same remainder so you kind of start getting the picture. But let's go ahead and change the remainder. Let's say instead we did I to the 26th power. How many times does 4 go into 26? 4 goes into 26 6 times, remainder 2. So that means that this is going to match no longer I to the third, but it's going to match I squared. So I to the 26th power is going to be the same as negative 1. What happens if I have no remainder? Let's say I to the 8th, I to the 12th, I to the 16th, I to the 20th, I to the 24th, I to the 28th. Anything that is a multiple of 4, it's all going to match and it's all going to equal 1, just like I to the 4th. So if there's no remainder, your answer is 1. So how can you simplify powers of I? So step 1, ask yourself how many times does 4 go into the exponent they give you? Then determine the remainder. So if the remainder is 1, then your answer is going to be I. If your remainder is 2, then your answer is negative 1. If your remainder is 3, then your answer is negative I. If you end up with no remainder, that means that it goes in evenly, so the answer is 1. Go ahead and pause the video and try these 3 on your own. I to the 100, 4 goes into 100 25 times, remainder 0. Therefore, I to the 100 is 1. I to the 37, 4 goes into 37 9 times. 9 times 4 is 36. Remainder 1. So this is I. I to the 15th. 4 goes into 15 3 times. 4 times 3 is 12. The remainder is 3. So this is I to the third, which is going to be negative I. Remember that this pattern repeats itself every 4. So could I sit here and count for I to the 15th? Sure. I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and voila, my answer is negative I. But imagine, you don't want to keep doing that all the way to 100, right? So hopefully this is a better system. I hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.